Hey everyone, welcome to the third session in GH-200, Automate Your Workflows with GitHub Actions. I'm Rob Folkrod, a Microsoft technical trainer and long-term MCT in the developer and DevOps space. What we're going to be looking at right now is the idea of extending our workflows. And what I mean by that is that over time, if you build a bunch of different workflows, especially if you're working on, you've got a bunch of, say, .NET applications, or you've got a bunch of Java applications, what you're going to find is you're doing the same thing in pipeline after pipeline after pipeline. And any developer who looks at that replication, at that duplication, will often decide, hey, I would love to take like this little piece out, refine it, and then just be able to invoke that from whatever pipeline, right? We get that reusability. We'll also take a look at the idea of the individual actions themselves. I need to build one of those. Maybe I have built a script again and again. I have that same script included, and now I would like to make it a little bit more accessible to the people who are building these pipelines. So those extensibility points, with a little extra thrown in there, are what we're going to be looking at here inside of section 3. So specifically, we'll take a look at the idea of templating. So templates, we're going to start with, I've got the whole workflow. Can I make it easier for folks to start with that? And so we'll look at the idea of templates. We'll delve off a little bit off to the side and take a look at something called GitHub Script. So GitHub Script is a way that GitHub, that our pipeline can interact back to the rest of GitHub. So maybe I need to create an issue. We've gone through a build, maybe that build failed, and I need to write back to GitHub and create an issue. Well, there's a REST API there, but we have a nice little helper that kind of sits over the top of that. We'll make that a little bit easier. So that'll be quick in with scripting. And then we'll get into the final bit. How do I build my own actions? Actions is the name of the game, right? So how do we build our own? And we'll see there are 3 different ways of doing that. We'll start with kind of the closest to home, being our composite actions. We'll then delve into, I need to program and it'd be a little bit more complex. So we'll look at JavaScript. And then we'll go even slightly further afield with the idea of Docker container actions. All right, so that's the module at hand. Let's get into it. So the first is workflow templates. Now you may recall, if you were with us back in session 1, that we were talking about like, how do I find actions? And we go up to the little action section there, and there are a bunch of predefined templates that are just there, right? The folks who have built some .NET applications, there's one sitting in there for .NET, there's one sitting in there for like a Spring application if you're in the Java world. And when you click on that and start, there's already the bones of a workflow. And then your job is to go in and finish it. You'll go in and make whatever modifications you want. You'll go in and clean that up. However, if what you're trying to do is make it easier for the developer and the DevOps folks who follow after you, maybe you have a series of best practices. Maybe you say, listen, if we're going to be building a .NET application, here's what we recommend as the way that you're going to start. And we can take that recommendation and not just make that recommendation a Word document and hand it to them and hope that they follow the Word document, but instead, it's just a thing that they click on. When they go and say, I want a new workflow, it's one of the templates that are there, and they can just click on it to begin. Another option is what's called a reusable workflow. In a reusable workflow, you have built maybe a job, maybe half a job, and those 5 steps are used again and again and again. Those 5 actions are used again and again and again. So in that scenario, what you could do is you could just take those as a separate file. So if we look here, we will see that we have a little workflow. We're calling the workflow standard CI, and this is in its own individual file, ci-standard.yaml. And the action, the event that is triggering this, is not a push, it's not a schedule, we saw those earlier, but instead it is a workflow call, meaning some other workflow is looking to me, to this item, saying, I need you to run right now. So you can imagine that we have this little component sitting out there, standard CI, ready to go. And it could be, just call it good at that point. Or you could go further and define one or more inputs that might be used. So in this case here, we have an input called environment. It's up to you. The name is up to you. You can define whatever that is. In this case, we have one called environment. You have to pass that in, and it's going to be a string. Great. So that's how this is going to be invoked. What are we doing in here? Let's imagine this is as complex as we need. In this case, we have 3 steps that we're running again and again and again. We are checking out our source code. We are doing an npm install and running tests. And then we are printing out to the screen, hey, we just did environment such and such. Your world will be more complicated. I need it to fit on the PowerPoint. So we've got those 3 steps. Okay. Those are built. Those are ready to go. How do we invoke this? In another job somewhere, externalized. We're building a job called call reusable, give it whatever name you want. But you'll notice here the uses. And in this case, the uses is specifying the path to that reusable workflow. And as we saw up above, it is requiring an environment parameter to be passed in, so we're coming up with environment prod. Now, without really having to learn any new skills, without having to delve into JavaScript or any other language, we're just using what we already have, in essence, cutting that out, putting that in as a reusable workflow, and then invoking it. Now, we're going to veer a little bit outside of what we've been doing and talk about GitHub script. So your workflows very likely at some point in time will need to interact back with GitHub. You will need to create an issue. You will need to add a comment to an existing issue or add a comment to a pull request. You will need to invoke another workflow. Whatever it happens to be, you've got a lot of opportunity for the pipeline itself to call back. So to do that, we've actually got kind of 3 different layers where that's possible. Layer number 1 is REST. You simply invoke an HTTP request back to GitHub and basically do it on your own. REST is easy because it's available everywhere. REST is complicated because it is kind of formless in the way that we put it together. So the GitHub team built a library called OctoKit. And OctoKit is a tool that is a thin layer that sits above that REST interface. So now you could use OctoKit to make those invocations. OctoKit itself wasn't incredibly easy to use. Right? The authentication layer is still visible to you, so you've got to figure out how the authentication works, and so it's a little bit on the cumbersome side. REST, OctoKit, and above that, finally, the hero of the story, GitHub script. And GitHub script, it presents to you a fully authenticated OctoKit client, ready to go, where you can just make an invocation. So for example, here, we've got an action that is using GitHub script that we pass in our secrets GitHub token. We have seen this guy before in earlier sessions. And then we have a relatively straightforward invocation. We're using github.issues, and we're calling out create comment. We don't need to know the underlying REST API. We call out create client. We pass in the parameters, what's the issue number, who's the owner, what repo are we looking, and what is the body that we want to add to it. And whenever this particular workflow runs, new comment is added. Right? A relatively straightforward way to interact, to extend our workflows to be able to talk back to GitHub. Now, the only downside to what you just saw is that script can still get a little bit ugly. Right? There can be a little bit of work here. So we're just going a slightly further afield here. We're still calling out GitHub script, but in this case, we are passing in an actual script file. Right? When we're building workflows, we are already in the YAML language format, whatever you want to call it. And having multiple languages nested inside does add a complexity. So instead, just have JavaScript for JavaScript. So we build a little script JavaScript file, and then we pass that in. Makes it a little bit easier to maintain long-term when you just pass in an external file. But other than that, very much the same. Right? So you can either script it directly. You'll probably, it's easy to start that way. But then when we want to add a little bit of maintainability to it, and really add testability to it as well. It's far easier to test an external script file than it is to kind of test it inside of the workflow. So, second way of handling that. So, good start. But what we really need in a lot of scenarios is, I don't need, the template is great, right? The taking an existing series of 4 or 5 actions, that's fine. But as you get deeper into it, you're really going to need to start to build your own individual actions. They will often start as your own bash scripts or JavaScripts. And you find then that they're starting to get a little cumbersome. And you find that they're being used in workflow after workflow. And those two things of both cumbersome and repeated make it difficult to maintain. So at that point, it's like, I just need to pull this off, and I want something as easy as some of the other actions that we saw. If you were with us in the previous session, we saw that there was an Azure action to deploy to Azure Web Apps. Right? There's a lot of code going on behind that we didn't have to see. We just said, deploy to Azure Web Apps. This is the effect that you are giving either yourself or other developers when you start to build your own actions. We're going to see there are 3 different ways for you to build your own actions. There are what are called composite actions, JavaScript actions, and Docker container actions. And they're kind of in the order of complexity. Composite actions are similar in structure to what we saw with reusable workflows, in that we can build these out of YAML if we want, but if we need to include a couple external scripts, great. So I said here JavaScript, but that could be, right, that could be Bash, that could be PowerShell, that could be whatever. Just additional supporting scripts that go along with it. But still YAML in its structure. If you go and take a look at the built-in actions, and you can do that at any point in time, but most of those actions are just repositories inside of GitHub. So for example, if you right now, if you're like, well, what does this look like? You can go to github.com/actions/checkout. That is one of the actions, github.com/actions/checkout. GitHub/actions/checkout. That's the name of it. And you go there, there's a repository. And in that repository, if you delve deep enough into it, you will see that that action is written in, it's technically written in TypeScript, but ultimately it's in JavaScript. So you can also build your own actions very much like that. So JavaScript is kind of the default way that those are put together. Now, it might be that JavaScript is either not your cup of tea, or that what you want to do is just easier in another platform. So we might be looking at the world of like Python and say, listen, someone already built a library in Python that does 90% of what I need, and I just need to invoke that library. But we need to also have that Python environment come along for the ride. So the way that we can do that is through Docker. So when we're looking at Docker container actions, we're moving beyond just JavaScript and having multiple platforms. So we'll take a look. We'll dive into a little bit of each of these three. Starting with composite actions. So, as we said before, composite actions are going to be a combination of two things. One, you get to stay with what you're already doing well. You're already in YAML. You're already having sets of actions that are in play, and you just want to bring those together under a single umbrella. Right? So similar to that reusable workflow idea, but we also get to include additional scripts. So the first thing that you're going to do if you want to build one of these is you're going to set up a directory structure that will support this. So in this case here, we're going inside of GitHub/actions, and we are then defining the name of our action. So when we were doing reusable, we were actually pointing to a specific YAML file, and we said like that was the name .yaml, right? Here we're going to be pointing to a directory, right? And in that directory you will have a root object named action.yaml. Action.yaml will have the structure of what's happening, and that action.yaml optionally could call out to one or more scripts. In this case, we're calling out to a bash script, right? So a shell script. But this could be whatever kind of scripting language is supported by the underlying runner. So you're looking at, in many cases, like PowerShell or Bash as options that might be supported on your underlying runner. And so the action YAML file is where a lot of the magic is happening. So in this case here, we're giving it a name and a description so that we understand what's going on inside of it. We are defining what parameters you may be passing in. And this is where some of the ease of use comes from the consumer, because they don't need to know the underlying details and the if statements and the switches and things that you have to make this work. They just get to pass in a parameter and it behaves a certain way. So here we are specifying an input of node version, whatever, right? Whatever the input is, that gets to be up to you. And in this case, we give it a description and whether it's required. Then we have the job, the runs, and here using composite. Right? So one of the things that's a little bit different from what we saw with the reusable workflows is that we don't have a trigger here, right? Where that last one had a custom trigger. Instead here we have this using composite, which gives us that idea that it's the composite action. Then whatever steps are necessary. So in this case, we're doing a checkout and we're setting up node, whatever is necessary. It could be 5 steps, could be 25 steps, could be whatever. Then to consume this, it is a matter of pulling in a uses and passing in that directory structure. Right? This may be in the same repo. This could be in a different repo. We'll talk about this a little bit more when we get into our final section. But in this case here, we're looking at the same repo, GitHub Actions, and then your directory. And we're passing in that structure. If we had to go further, then we would specify the owner or the org, followed by the repository, and then the location where we're going to find it. So not a lot new when we're looking at composite actions, which is kind of one of the benefits, is that we didn't have to learn something completely different. Instead, we got to kind of stick with what we knew and reuse those. So a good place to start. But as we need to get a little, if right now we're using existing actions, but what if what you want to do is just not even there? There's nothing to reuse. You need something brand new. When you need to build your own individual action, JavaScript actions are the way that you will often go. These may be just in your own repository, or they may be in a separate repository unto themselves. Earlier we mentioned that the action/checkout, a built-in action, lives in its own repository. You can go look at that repository, look at the repository structure. We will see that here. The component pieces that you're going to want. These are going to be a little bit different. Keep in mind, the center piece of all of this is a JavaScript file. But the entry point, the what does the definition look like, is still inside of YAML. So you will start with having some sort of action.yaml file. This file here will describe the inputs, the outputs, and will also say, hey, what is the JavaScript file that we need to run? So that is often in a subdirectory, right? So here, the next step is, okay, what is that JavaScript file? So we'll have an index.js or whatever you want to call it, whatever is defined by the action file that points to it. And then you will push in there, you will push the action file, you'll push the JavaScript file, and counterintuitive, you're also going to push all of the node modules and the package lock file. Typically, when we're looking at our own repositories, we forbid the node modules because that's going to be part of the build process. These don't have a build process, so you will need those node modules to also go along for the ride. So, as we said, you could either build your own action directory or your own repository. In this case, we're going to build our own repo, right? It'll have a little .github in there, right? Then our actions and the name of your action. Right? So this could be in the same directory as your other workflows. Often, for reusability purposes, it'll be in its own individual repository. So we built the directory structure. We know where it's going to live. Then we're going to build the action YAML file. In the root of that directory, we will define the name of the action, a bunch of metadata about its description, who wrote it. And then you will have the inputs described in YAML. As many inputs as you want. In this case, we only have one, an input called version. Again, these are up to you to define. There's nothing magical about the word version. Whatever parameters that you need to pass into it are going to make sense for you. Version has a description, whether it's required or not, and a default. If it's not required, then it does need a default, so that we know what the value is if it's not run. Then a runs section, where we're going to specify what version of node to load up when we run this action, and where is the entry point. What is the JavaScript file that contains the code that defines the action? So you can imagine this is kind of the interface file that then points to the real JavaScript file beneath the covers. All right, so once you have the definition of the interface of what your action is going to look like, we then need the body. What is your action going to do? And that is the JavaScript file itself. Now, the JavaScript file needs a way to kind of get context. So, for example, you passed in a parameter. How does the JavaScript file get that parameter? Where is that coming from? And so one of the things that you're going to get used to in this is a library that your action will use to kind of get its context. What is the world that I am running in? And so that library here is actions/core. So we start off with core, and then from core, remember in the earlier slide, we had a parameter called version. And here we are going ahead and getting the value of that. Now, in that earlier slide, admittedly, we didn't need a default, and there was one supplied. But here we're just covering our bases just to be on the safe side. So we're supplying another default just in case it wasn't already there. But grabbing the version, and then do what you're going to do, right? Carry on the actions that you're going to carry on. And in this case here, we're logging out that we're installing this a particular CLI. We're going and grabbing that CLI version, and off we go. So we've built a quick little component to grab a CLI and install it. So that's our action. So we started with, again, the YAML file that described it and pointed to the JavaScript file. And then the JavaScript file kind of reads what's going on by way of that action. That's our JavaScript. Going a little bit further, what if JavaScript's not your bag? Or what if the libraries that you want aren't as readily available? Right? Python being an example of a language that has so many libraries, where it could be 90% of what you want to do is already done with a function call to a particular library. In those realms, what we're going to have to do is we're going to have to build a Docker container that contains the components that we want. So you're going to build a few things, some similar, some different. Right? The biggest difference being that you'll have a Docker file that will define your environment. You will continue to have an action that describes the interface. And instead of pointing to a JavaScript entry point, it's going to say runs a particular image and then point to that Docker file. Inside the Docker file itself, you will have some sort of entry point, some sort of code that will be running that will point to the real component. So let's look at kind of how this works, because this is going to be a little bit different. When you're calling out to Docker from the workflow, that will then start the life cycle. This isn't something that you do ahead of time and then push that Docker container somewhere and call from it, or doesn't necessarily need to be that. You can call into just kind of a raw file. And so your workflow invokes, for whatever reason. We really don't care in step one why your workflow is running. It's just running, however, whatever trigger started it. Then you point to that particular action, and beneath the covers, then the virtual machine is going to start up, run your action, and it'll end up calling out to your Docker file. It'll see the action YAML. That'll point to the Docker interface. That Docker interface will then either go through the Docker build process, which could take a minute. Right? So this is not necessarily something that's going to be super fast, exam folks. Bad thing to remember. Anyway, it's not going to be super fast because we may have to go through that build. So this could be valuable if we have to do it a bunch of times in there, great, or there's just no other way. Yeah, but this is not necessarily going to be your fastest action. So the Docker file is then built. Right? Then we go through the container executions, load it up into memory. We hit the entry point, which is pointing to our script, and we may get some results back. So we'll see in the demo a little bit later, putting one of those together. All of these actions, they have to live somewhere. So where are they going to live? And you've got kind of the two basic options of publicly or privately. So they all may live in your own repositories. It may be that the repo that is running the workflow is just pointing to a directory inside the same repo, and your actions are all here. The downside is you built actions for reusability. And now, the only one that gets the reusability are the workflows inside the same repo. These get the benefit, pointing to that same repo. However, a secondary repo over here may not have access or knowledge of those. So it may make sense to have a private repo that is just your actions. And we'll see this in the next section a little bit more. But then external repositories could call into these. Now, in this scenario here, these are still private. These are still yours. The outside world doesn't get to see your actions. Whatever's happening inside of these belong to you. If we want to go further, we can also store those in public repositories. Then, maybe not only your organization, but other organizations can also take advantage of those. Either way, you are building these typically for other people, even if it's just you 2 months from now. At that point, you're still other people. You're not going to remember what you did. So make sure that we have decent documentation. We talked about the action.yaml file being the entry point. It's a fine entry point. If you are learning a new action, it is not a bad idea to open up that action.yaml file, dig into it, and see what's going on inside of that file. However, it's a YAML file that is a work file, right? Its job is not to be easy to read. Its job is to get things done. That's where the README file comes in. If you are building your own actions, do include, there's nothing that's going to make you do it, but do include a README file that describes in detail what do those input parameters mean? What is sample code that you can use to invoke this? I would recommend that you also go take a look at what is already out there. Go to actions/checkout, github.com, actions/checkout. Go read that README file, right? Anytime you have an issue, have a problem, go read that README file. It'll give you, one, good perspective on what belongs in a README file. It's also a great place to learn that particular action. And then there's versioning, right? Your actions, one of the reasons that we pulled this out is because that when there are changes that are necessary, you want a single spot where you can go make those changes. But then we also need a way to signal, hey, this has changed. Because we don't want code that someone else built earlier to break because you invoked change. Right? So we need this balance between changeable but also documenting those changes. And so we need some sort of release process. When you are referring to an action, you will typically see you'll see some sort of version in there. Right? This is not an accident. Someone has consciously gone through the process of saying, okay, this particular commit is now version 3. That's often done by way of tags. So in the repository where this lives, which is often why they have their own individual repositories, because we can then control them independently, you can then place a tag on a particular commit. And then you have flexibility in using them. Right? So here, actions, they're just making the one up, JavaScript action, that's a fictitious name. But there is a tag in there called v1. There's another tag in there called v1.0.1, right? And then one called v1-beta, right? Where now you, as the maintainer, have control over that tag and can move that tag as need be. You can also, as the consumer, You can refer to a branch. You can refer to, obviously, a tag here. You can also refer to a SHA that refers to the absolute commit itself. That is the one that will that will never move. So you have control over where those are being placed. But as the maintainer, we'll probably use tags as a way to make it easy for our folks to refer to our actions. And then this is an optional step. You can build actions and keep them to yourself, okay? But you can also then publish those to the GitHub marketplace. If you want to make them available, you've got something that you think is going to be valuable to more than just your own independent self, your org, you can help contribute to the open source nature that is GitHub Actions. And you can publish those to the GitHub marketplace. Typically at that point, they will be in their own repository. And then folks will be able to look those up and find them and consume them from your repo. Okay, folks, time for another show and tell here. We're going to do a few things in this one. We're first going to start with the idea of templates for the entire workflow. Then we'll dig into if we want to reuse individual pieces. As you recall, there were 3 different options. So we will take a look at Composite, JavaScript, and Docker. And then finally, we'll wrap up with a little bit of the GitHub script idea that we saw earlier. So first and foremost, when you have maybe a best practices where you want folks to be able to grab an entire template as a starting place, there's a really simple option here. So what you're noticing, what you may see here, is that I am in my org right here, but specifically I am in the .github repo of that org. And this is a special repository that can serve as the templates for your entire organization. Specifically, I have a directory here. The directory name is important, workflow templates. I'm going to dive into workflow templates, and you will see 2 files in particular. You will see a YAML file that has the template directions in it, along with the metadata document to describe it. We'll start with the template first. And this isn't anything new. It's not anything interesting. It's very similar, actually, in scope to what we saw in the earlier example in the previous module. But we're giving some idea here on what should jumpstart the app. Any user, you'll see in a moment, any user could go ahead and change this. This is not mandated. This is just a suggestion. Some environment variables that may be handy throughout the app. And in this case, we've got a few jobs. We've got our build and test job again, and we have at the end of all of this a deploy job. Right? So we might say that anybody who's going to be doing .NET CI/CD needs to have at least those 2. Have as many in there as works. I'm going to back up a step. We also then have a properties document that matches in terms of name, .NET CI/CD.properties.json. And this has a human readable name, a description when another developer, DevOps person may want to take a look at it, what the icon is supposed to look like, some of the categories that it will appear in when we see it, and what in your project indicates that this may be an interesting option. So given that, we could be in another repository. We're just going to swing into some sample repos here. We'll drop into our play document here. We'll go into actions, and we'll say we want a new workflow, right? We're just starting from scratch. We want a new workflow. When we click new workflow, it's got some of the suggestions again from earlier, but you'll notice that it also has this one right here. This is my organization. So this is the template that we created now as an option. Anybody in this organization, when creating a .NET application, will be suggested that they use this one. When we hit configure, Same approach, right? We're starting a brand new, there's a file name, but it's now ours. Right? We are at no point obligated to take any of these. It's just the file to new, if you will, structure that looks pretty good. So this might be part of your best practices team that may go out and devise what a good template looks like for a Node application or for a Python application. So that's option number one. That's reusability at the large scale with the structure of the application. But we also have then, as we saw in the PowerPoint earlier, we have several options when it comes to breaking down and building our individual actions themselves. So we will take a look at all three. We'll take a look at Composite, JavaScript, and Docker. We'll start with Composite. Composite is really the most straightforward. That inside of Composite, you could build this in your GitHub directory. You could build this in the local directory. But we are really just looking at the YAML file. We don't have to learn any new skills. If we wanted to have some composite scripts, some additional scripts that went along for the ride, those could be in the same directory. But this is an important, the directory name here is important, Actions Composite. Inside, we should have an action.yaml. Name isn't interchangeable. It will be action.yaml with any supporting files that go along with it. But what's nice here is no new skills. We devise what our inputs are going to be. What do we need to pass in? What the outputs are going to be. In this case, we have a greeting message output and a timestamp output. And then a runs section. Instead of a jobs section, we have a runs section. And we're specifically saying how with the word composite. We know this is now that first option. But then when we're inside, this is just the same GitHub Actions that we've seen all along. There's nothing incredibly new or interesting in here. This particular example, I'm just running a bunch of different bash scripts, but this could be any of the existing actions that you may want to compose and bring together, hence the term composite. All right, so these are all just individual scripts that may be running. To invoke this, we have a job here. This is in another action. We have a job here just called run actions, right? The name isn't really all that exciting. But in this case, we are running the composite. So we are using the uses and we're specifying that directory name, not the full path to the YAML document, but just that directory name, action-composite. The two parameters that we're passing in, include greet and greeting style. This action will then run. Now later on, remember that it had not only input, but also had output. We could read those outputs. Remember there were two, there was a greeting and a timestamp. So from here, we're calling out to steps, composite action. That matches, I get the zoom just right here. That composite action right there matches the ID of the step that invoked it. Once we have that, then it's outputs dot, and those two outputs that we saw, greeting dash message and timestamp. Option number one, composite. Option number two, if what you want to do isn't easily composed of existing pieces, but needs to be something of your own creation, then we have JavaScript and Docker. JavaScript is of the more common. Notice again the name here, action JavaScript, not being very clever with it, but it will also have an action.yaml. Now this one will be a little bit different. Instead of having the functionality inside of action.yaml, we will have the inputs, We will have the outputs, what we're passing back. We will have runs, and then we're saying node, telling us it's a JavaScript application. And then we describe where the actual code exists, because it can't be here. So in this case, we would be looking to index.js. This particular index.js, and not the most clever, but we are starting off with how do we read those inputs and outputs? So we're dipping into the actions library core. So anytime you see core here, you know that we're pulling from there. We're displaying external output, but then inside of core, get input. There's the input text and the operation value. Continuing then, at the end of all of this, we have those set outputs. Those 4 options that we had: text, operation type, timestamp, and metadata. But then you build internally JavaScript, whatever the behavior is that you needed to replicate, that you needed to repeat again and again. The invocation will look relatively similar. We're setting up node here to make sure we've got that up and going. And then we're going ahead and running action-JavaScript. Right, there's the name of the folder that it lives in. It then looks to the action YAML, finds the input, the outputs, and the entry point. We pass in our inputs, outputs, and again, very much like we saw, the invocation looks very similar when we are using JavaScript. Third and final option we have Docker. And Docker can be more interesting when what we're looking at isn't necessarily going to be on the system, whether it was like Python, or maybe you needed you had some functionality in Ruby already or Go, and that runtime isn't going to be guaranteed to be on the runner. So here again, the entry point is going to be action.yaml. It will describe the inputs, the outputs that are going to be necessary, but then we have runs and using Docker. Instead of having an entry point like a JavaScript file, we're specifying what is the name of the Docker file, traditionally capital D Docker file, and the args that we're going to be passing into that container. We dip into the Docker file itself. We'll see here that we're grabbing a relatively tiny image, right, from Alpine. You are going to be, these are the slowest of the action types, because in many cases we are doing a full-on Docker build before that happens. So you want to make sure that you're not grabbing incredibly large images in this case. Install whatever dependencies you might need to be up and running. In this case, we're just running a particular bash application, but we want to ensure that we have certain dependencies already in place. And then we describe, we load up the document. In this case, it's just entry point.sh, but this could be any number of files that need to be loaded into Docker file. We make sure that those are executable. And then finally, we set that up as the entry point. This will be how we describe what the first action is supposed to be. In terms of evoking, very much the same, right? You're not going to see a ton of differences here. Give it an ID. Again, that same folder structure is what we're pointing to with our inputs. It's running at that point, right? And then we can go grab the outputs as need be. So our 3 options, again, composite, when you want to reuse what you already know with YAML, JavaScript which is kind of the default strategy when you're building your own individual action. And then Docker when we have to go outside of the boundary of a node. Okay. Now we're going to take one last little look, staying in the world of JavaScript. But you may recall when we were talking about all of these reusability aspects, there was just one little piece in there that says, well, what if what I want to do isn't necessarily I want to build my own individual action, but I need to interoperate with the world of GitHub. And so we have an example here that actually came from our earlier example. If we swing down to this PR comment, you'll notice that we do have a step here that says comment the PR with coverage. So in this world, what I want you to imagine is that a pull request is taking place, and you are the reviewer of that pull request. When you are reviewing a pull request, you want to get as much information as possible into the pull request itself, so you don't have to go out and start looking and gathering up information. So in this particular scenario here, we are using the GitHub script action. And we just have a tiny little script right here. Earlier in this workflow, we calculated some code coverage numbers. And those are sitting inside of this summary github.markdown file. Up above, those were generated. Well, what we want to do is we want to make sure that information is available to us while we are reviewing the pull request. So in here, we're going to use this github.rest. That's our entry point there into GitHub script. In this case, we're going into the issues component, and we're creating a comment. Now, this issue that we're using, built in, there is this context.issueNumber. That's the pull request we're in. So if there's a pull request 2 or 28 or 200, whatever that is, we are now adding a comment to the current pull request. We're specifying the owner, which is the owner of this organization. We're specifying this repo, and we're just adding a message that says code coverage report, and then adding that coverage information. Taking a look, if we track it back, you'll see code coverage is just coming from reading the coverage file. The coverage file is that summary. As a result, when we have something that is a pull request, you'll notice right here that we are very specifically saying this particular step only runs on pull requests. Then the pull request itself will now have this code coverage report. So we don't have to go back into the action and start digging through and seeing all the results. It's simply been added to the current pull request. All right, so there you have it. A few options when it comes to extending and reusability inside of GitHub. My friends, we've talked about a lot, right? We have talked about the idea of reusable templates. We talked about the idea of reusable workflows. So the template is the grand scheme where the workflow might be 4 or 5 steps in there. We took a little deviation out to the world of GitHub script, which allows us to interact with the GitHub environment. And then we looked at 3 ways to make our own actions, kind of increasing in complexity. The GitHub action, the composite actions, is a mechanism where we can kind of stay in the world of YAML and use existing actions. JavaScript actions are when there isn't really an action to reuse, where we need to start building from scratch. And then Docker actions, same idea. There isn't really one to reuse. However, I may not be dependent on the JavaScript language, and I need to veer outside of that. So we see Docker at that point. My friends, I hope this has been helpful to you. I hope you have gotten a lot out of this. I also hope that you're going to see me in the next section, our 4th and final section, where we will be looking at moving beyond just individual repositories to looking at the organization level, and above that, the enterprise level. I'm Rob Folkrod, and I hope to see you there.